Hey Freshies, this is your scientific assignment. It's going to be a 2-day process. So we're going to do day 1 today, and then in 2 days we're going to do day 2. So you guys will just have to check the agenda for when those 2 days fall for you guys. But if you miss one day, obviously you only have to cover one day. If you miss both days, make sure you guys come up with both. So this is the Finding Bigfoot versus MythBusters. Who does the scientific method better? Your learning targets for these 2 days of assignments. I can identify the steps in the scientific method. I can explain ways in which other scientific work is flawed based on my knowledge of the scientific method. And I can identify ways in which the scientific method has been done correctly. Okay, so you guys will be working through this assignment. The first page of this is your notes. Okay, so this is one of the 2 options you guys have in your notes. This one's a little less detailed, but the scientific method starts out with just basically an observation. I see this happening, okay? And then doing some research and finding a question. And then from that question, you would write a hypothesis, which is a testable question, okay? So an if then because statement, typically, if I change this, then this will happen because, and typically your because statement comes from research that you've done when writing your question, okay? You're gonna make a plan. That would be kind of your steps of your experiment and all the things you need, okay? Then you guys would actually run your experiment and collect data. Then you guys would probably take your data, put it into some kind of data table or graph so you guys can see relationships in your data. If I change this, what happens to this? Okay, and then from that data, you would analyze it and critique it and look at your guys' steps. Did you guys run your steps right? Do you guys think you had bias? Meaning you guys kind of saw one way no matter what the actual results were. Okay, you would write a conclusion. This is often very similar to a CER where you guys draw your conclusion, which would be your claim. You guys support it by evidence, which would be your data. And then you kind of explain why that evidence matters in supporting your claim or your conclusion. Okay, a lot of times with scientific method, we kind of have to redo it, all right? If no logical explanation, go back and rewrite the hypothesis. So you guys would tweak your hypothesis a little bit, maybe do a little bit more research, tweak your experiment just a little bit, run through it. Maybe if you guys thought it was great, but you want to retest it to make sure it's replicable, you would go back through and run the exact same experiment. So you kind of get stuck in this little loop of conclusion, hypothesis, retesting, recollecting data. You want you to be able to go through this cycle several times and get the same data. Okay, if you're getting weird data, then you again would need to kind of retweak your hypothesis and your experiment to collect new data. Okay, another way of looking at this is a little bit more in-depth. So again, it starts with an observation or a question. You do some research, collect existing knowledge, you hypothesize, you design your experiment, you collect your data, and then from there, you can either draw a conclusion or you can go back and kind of, wait, what did I see here with my data? Let's go back to my observation or question and run through that cycle again. With the conclusion, you kind of have a yes or no. Yes, it adds to the knowledge. Okay, we've added to research, or no, it does not. Okay, so we would create a new hypothesis and keep working through this. Okay, peer review is a really big one with the scientific method, where other scientists in that community or along that same lines of research take a look and say, was your data valid? Did you do your experiment correctly? They try to look for ways in which you did things wrong, and that's kind of how we get to drawing conclusions on theories and laws, okay, is we have a lot of people who try to disprove it, and if they can't disprove it, then that says a lot for your work, okay? Some other things you guys might look at is the difference between a hypothesis and a prediction. So a hypothesis attempts to explain the why. So you say if then because. If I change this, then this happens because. So we're trying to explain the why. Whereas a prediction is just what do we think is going to happen. Okay, so we always want to make sure we have a hypothesis and not just a prediction. We always want that because statement. Okay, with our design, we want independent and dependent variables. Our independent variables are going to be what the scientist chooses to change. Okay, maybe you're changing the temperature and seeing how long it takes for ice to melt. That's your dependent variable, is what is measured, okay? So then we'd be looking at time for ice to melt, okay? Good experimental design, we have a large sample size. We don't just do it once. So if we're doing an experiment on humans, like a sleep study, okay, we're not just gonna use one human being, we're gonna use hundreds of human beings to see if our data is actually conclusive. Okay, you're going to have only one independent variable. We're only going to change one thing at a time because we want to know if our data, our conclusions come from that one change we made. If you have multiple changes, you're not going to be able to identify which change it came from. Control groups is going to be your normal conditions. Okay, so maybe we have one plant that we give water to and then other plants that we give soda to. Okay, water is our normal, what we would normally use to water a plant, whereas our soda groups would be our independent variables, and then our growth would be our dependent variables. Constants are the things that we're going to keep the same. Again, remember that we only want to change one independent variable at a time. So if we're talking about the example of plants and we're changing as our independent variable the types of stuff we water them with, we're not going to change the amount of sunlight they get. Those are our constants. Okay, and then finally, there's a pattern between variables that's called correlation. So when we're looking at our data and drawing a conclusion, is it kind of a coincidence? Okay, or is it caused? Like, because I changed this, it caused this. Think of cause and effect there. So that's correlation versus causation. Finally, scientific theories explain natural phenomena. They're really well tested and widely accepted. When they went to this peer review process, people couldn't disprove them. Okay, so this is a little bit more in-depth. I like this one a little bit better. Okay, so moving on from here. Okay, day one, you guys are going to be watching an episode of Finding Bigfoot. I have that link there for you guys. It's a YouTube episode, so you guys should be able to watch that from home if you're gone for day one. And here are the questions you guys are going to answer using your own words. What is the question being asked? What is their hypothesis? So what's their prediction they're going to make? How are they going to test it? Okay, how did they design their experiment? So what did they plan to do, or what did they do? And then did they repeat or modify the experiment? So we go back up to our notes and we kind of look at this little loop where we keep coming around and repeating our experiment to see if we get the same results. Okay, did they do that, or did they just run their experiment once and say, yep, Bible, this is the end of this. This is our final data. Okay, what evidence did they collect? Is this evidence measurable? Okay, meaning can we form data from this? Can we have actual facts and data and numbers and things like that? Is it replicable? This is a big one. If they were to run this experiment over and over and over again, are they going to get the same data? If you run an experiment more than once and you don't get the same data, you got to keep running it until you get it, or tweaking it until you get data over and over. Otherwise, you can kind of chalk your first one up as a fluke. Okay, this is an anomaly, wasn't supposed to happen that way. Okay, what flaws did you notice in their scientific method? So again, refer back to your notes for theirs. There's going to be a lot of different flaws that you guys see with this. And then do you think their conclusion would be scientifically valid? Meaning that if we took it to the scientific community, okay, would they support it and be like, yep, that's some good data. You ran your scientific method perfectly. This could be a big discovery. Okay, so do you think it's scientifically valid? Use your draw tool to circle yes or no, and then explain why or why not. Okay, was their conclusion supported by evidence? So think of a CER. Okay, they make a claim, they use evidence. Did they use good evidence? Think about what evidence is and what evidence is not. Is it an opinion or is it facts? Okay, is it data or are we just kind of throwing stuff out there? Okay, so make sure you explain that as well. Use your draw tool for that. Okay, your exit ticket for day one. What changes could be made to Finding Bigfoot's method to make it more scientific? So you guys should list a couple there. Remember, real science requires measurable, testable, and repeatable evidence. Okay, day two, if you guys are gone for day two, you'll need to watch MythBusters. Unfortunately, I don't have a link for you to do that at home. Okay, so you'll need to see me. I'll do probably 2 lunchtime showings for this year, probably Friday and Monday, so the next 2 days. So if you guys are gone, you'll need to come in one of those 2 days to watch this MythBusters episode. Okay, realistically, you guys could probably watch just about any MythBusters episode, but for today, we're watching season 1, episode 8, called Penny Drop. Okay, so what question is being asked? What is their hypothesis? How did they design their experiment? Did they repeat or modify? So did they do it over and over, maybe making changes each time? Okay, what evidence did they collect? Is the evidence measurable? Could they collect actual data from it? Is it replicable? If they did it over and over, are they going to get the same results? Okay, what flaws did you notice in their scientific method, if any? And then did you think their conclusion would be scientifically valid? Yes or no, and why or why not? And then finally, what was their conclusion supported by evidence? You're going to use your draw tool to circle yes or no and explain why. Okay. And then finally, your exit ticket for day 2. After analyzing both shows, so you guys will obviously need to watch day 1 and day 2 and have those parts done before you guys do this exit ticket. Compare their approaches to the scientific method. Again, see our notes on slides 2 and 3. What are 3 differences between the way MythBusters and Finding Bigfoot use the scientific method? So I want 3 differences. I'll change that so it says 1, 2, and 3. Okay, and then which show is a better example of science? Okay, you're going to explain whether it's Finding Bigfoot. You guys can use your draw tool to circle this, or whether it is MythBusters. Okay, so circle which one and then explain why. Okay, this is going to be due on Friday. Again, if you guys are gone though, for day 1, you guys will be able to do that at home. Day 2, you guys will have to come do one of my lunchtime viewings to get that part made up. And then you guys should be good to go from there. This is due Friday. If you have any questions, please let me know and I'll talk to you soon.